Hello everyone, I'm Paul and today we're solving problem 2125, number of laser beams in a bank. This is medium and next I will show you my intuition, approach and efficient solution. We are given a binary string matrix corresponding to security devices inside a bank. So let's say we are given this matrix and here you can see how this one corresponds to a different security device. For example, here we have 3 at row 0, these 3. Now, we have laser beams in between two security devices. For example, here we have one laser beam, and in between this and this, we have another laser beam. Now, we only have a laser beam in between two security devices if there's no security device in between these two. For example, there's no laser beam in between this and this. Why? Well, because we have these two in between. Okay, this is very important. Our job is down here. We need to return the total number of laser beams in the bank. For this example, the result is 8. We have 2 here, 2 here, 2 here, so this is 6, and 2 more here, 8. So we return 8. And maybe you are thinking about building an adjacency list for lasers. For example, this is connected to this and this, and this is connected to this and this, and so on. And after you have the adjacency list, you can run a breadth first search. Remember that here we move in circles. We start from one node and we move to adjacent nodes. And then we repeat the process and we move to adjacent nodes again. So we are moving in circles. For this example, we would start with these 3 lasers, then we will move to these 2, and then we'll move to the last one, okay? And this is fine, this might work, but it's a lot of work. We have a solution that's way more simple. And the key here is the following. Let's say we only have this and these rows. How many laser beams do we have in this range? Well, we have 3 security devices up here and 2 security devices down here. Now, we know that we have 6 laser beams in total, so we can just do 3 times 2, and the result for this is 6. And we can repeat the same process here. We have 2 security devices up here and 1 down here, so we can do 2 times 1, and the result is 2, meaning we have 2 laser beams. And if we do 6 plus 2, the result is 8. And this is how we can get this same result. And we can solve this with only 3 variables: previous, current, and result. We are iterating every row from top to bottom, so we start from row number 0. And every time we are counting how many security devices do we have each time. Here we have 3, so we put 3 in current. And now, given that current is greater than 0, we can do current times previous, and 3 times 0 is 0, and we add this to the result, so the result stays at 0. And now previous is current. We are updating this for the next rows. Now we are at this row. Here we have 0 security devices, so current is 0. And given that this is 0, we continue with the next row. Next we are here and we have 2 security devices, so current is 2. And now we do 2 times 3 and the result is 6, meaning these 6 laser beams. So we go down here to the result and we add 6. So the result right now is 6. And now we can replace previous with current, so this is now 2. And we are at this row, previous is 2. So given that we have only 1 security device, we replace this with 1. 1 times 2 is 2, so we add 2 to the result. This is 8. And now previous is 1. We continue, we reach the end, and we return 8. So this is the entire approach. We are iterating every cell in this matrix only once. So time complexity is big O of nm. and space complexity big O of 1. And with this in mind, let's go with the code. First, previous is 0, result is 0, and for every row in bank, current will be the number of ones in the current row. So we can say sum of 1 if x is equal to 1 in string, else 0 for every value in row. Now, if the amount of ones is greater than 0, we add to the result current times previous, and previous is now current. This is for next rows. And after all of this, we can just return result. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.